The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning insights into a potentially habitable exoplanet. It beckons us as we embark on a journey through space to uncover the secrets of Proxima B and determine whether it could be the next Earth. We ought to venture into the vast expanse of space, where a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock. It's a world of intrigue. Proxima B is located a mere 4.2 light-years away from us. This planet is shrouded in mysteries and wonders. Could it be another Earth, with oceans and life flourishing on its surface? But wait, there's more. Proxima Centauri B isn't alone in its system. Orbiting the red dwarf star, it has a companion, Proxima Centauri C. And who knows what other mysteries this star system holds? Perhaps there's another companion we have yet to discover. The secrets don't stop there. Proxima Centauri produces roughly the same amount of energy for its planets as Earth receives from the Sun. Could this truly mean there's water on its surface? And perhaps even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets. Planets that orbit stars other than the Sun. With an estimated 200 billion stars in the Milky Way, the opportunities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star like cosmic travelers in space. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. It has a year that lasts only 112 Earth days and orbits much closer to its star than Earth does to the Sun. In fact, one side of the planet is constantly bathed in sunlight, while the opposite side remains in eternal darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. Together, these stars form the closest star system to our own. The two stars, Rigil Kentaurus and Alpha Centauri B, create a binary system known as Alpha Centauri A and B. These G and K-type stars appear as a single bright point in the constellation Centaurus and are the third brightest objects in our night sky, with a peak luminosity of about 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf or M-type star, located 4.24 light-years from Earth. It is the closest known star to our solar system. In fact, Proxima means closest in Latin. Scottish astronomer Robert Thorburn Ayton Innes discovered it in 1915. Despite being our closest celestial neighbor, Proxima Centauri is not visible to the naked eye, as it has an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. Though they produce less energy than larger stars, their internal convection processes keep them burning for trillions of years. Proxima Centauri, for example, will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it is a flare star, meaning it frequently experiences intense bursts of radiation. As a low-mass star, its habitable zone is much closer to it than the Sun's habitable zone is to Earth, projected to be between 0.023 and 0.054 Australian dollars. But that does not necessarily make it hospitable. Proxima B is bombarded by intense ultraviolet radiation from its star, far stronger than the radiation Earth receives from the Sun. This extreme radiation strips away light elements like hydrogen, nitrogen, and oxygen, making it difficult for the planet to retain a stable atmosphere. And just because a planet is in the right zone does not mean it can support life. Without a stable atmosphere, Proxima B's surface may be inhospitable, with harsh space weather rendering life nearly impossible. So, while Proxima B might appear Earth-like at first glance, it is far from being a second Earth. Scientists remain cautious, as many factors make it unlikely to sustain life. Still, the mission to uncover the truth about Proxima B continues. Some scientists hold out hope, And one tool that has greatly contributed to our understanding is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2018, offering an unprecedented ability to study Proxima B. However, as with everything in science, things are never as clear-cut as they seem. Several adjustments were required to ensure the James Webb Telescope delivered accurate images. As Avi Loeb, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of Proxima B's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if Proxima B's atmosphere isn't conducive to life? The presence of an atmosphere does not necessarily mean the planet is habitable. As Ed Turner, an astrophysicist at Princeton University, warns, Proxima B could be more like Venus, shrouded in a thick, dense atmosphere with extreme temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope offers hope, many factors must still be considered. With rising costs, space scientists feel the pressure to develop innovative ways to observe planets like Proxima B. Much is at stake, but the potential rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that may hold the potential for life, is a pursuit worth chasing. If the exoplanet were to harbor life, it would redefine our understanding of habitability and the conditions necessary for life to thrive beyond Earth. Scientists continue to debate whether life could exist in extreme environments, and Proxima B provides a perfect case study. Future missions and advanced telescopes, such as the upcoming Extremely Large Telescope (ELT) and the Habitable Worlds Observatory, may offer further insights. These next-generation observatories will be able to analyze the chemical composition of Proxima B's atmosphere with even greater precision, searching for biosignatures, chemical markers that indicate the presence of life. Another exciting possibility is sending an interstellar probe to Proxima B. Projects like Breakthrough Starshot aim to send tiny light-powered spacecraft traveling at a fraction of the speed of light. If successful, they could reach Proxima B within a few decades, sending back direct images and data from this distant world. Despite all the challenges, the search for life on Proxima B and beyond remains one of the most profound scientific pursuits of our time. Whether we find a barren rock or a thriving ecosystem, each discovery brings us closer to understanding our place in the universe. Could Proxima B be humanity's next home, or will it serve as a cautionary tale about the limits of habitability? Only time and continued exploration will tell. For now, we look to the stars with wonder, knowing that with each new discovery, we are one step closer to answering the age-old question. Are we alone in the universe? Habitable. Might we one day visit it? It's the closest exoplanet to us, which makes it so intriguing, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima B's proximity also makes it an ideal target for our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't yet go there, it's certainly on the radar for future missions as technology advances. It's one of the most exciting endeavors in the field of space exploration. However, it's no easy task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system and Proxima B along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like anything ambitious, there are limitations. For instance, the presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that's inhospitable. Furthermore, get this, the James Webb Telescope can detect such emissions if they reach a brightness of only 5% of the daytime side. Now, 5% may not seem like much, but when dealing with a star that's generally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they may use bright orbital mirrors to reflect sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being gigantic gas giants while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been named superjupiters, surpassing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching world with temperatures that could melt metal. Imagine seeing such a planet up close, with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own planet. These planets come in various sizes, ranging from smaller than Earth to twice its size. There are even super-Earths, which have masses more than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass of 7 Earth masses. Although it is a relatively small exoplanet, it has sparked significant interest among astronomers and scientists due to its potential for habitability. Because of its position in the habitable zone of its star, there is the possibility that it could support liquid water on its surface, making it a prime candidate for life. Could Proxima Centauri be the answer to the question of whether we're alone in the universe? Only time will tell. As the quest for life beyond Earth continues, Proxima Centauri b remains one of the most promising targets in the search for habitable exoplanets. Its proximity, size, and position within the habitable zone of its star make it an intriguing subject of study for astronomers. Yet, as we dive deeper into understanding this distant world, several crucial questions must be answered. Does it have the conditions necessary for life, such as liquid water on its surface? Does it possess a stable atmosphere that could protect potential life forms from harmful radiation? Or is it a barren rock, constantly bombarded by its star's intense flares, rendering it inhospitable? While the James Webb Space Telescope offers a new avenue to study Proxima b in greater detail, it is not the only tool available to scientists. Ground-based observatories and next-generation telescopes, such as the Extremely Large Telescope (ELT) under construction in Chile, are also being developed to observe distant exoplanets in more detail. These massive telescopes will allow astronomers to study the atmospheres of exoplanets, including Proxima b, and look for signs of habitability or even life. The ELT, once completed, will have the ability to directly image planets orbiting other stars and detect the faint signatures of gases that could indicate biological processes. But even with the best technology at our disposal, the challenges are immense. Proxima b, like many exoplanets, is located incredibly far from Earth. Even with advanced telescopes, capturing definitive signs of life will require patience and perseverance. Detecting a planet's atmosphere is already a monumental task. Scientists must be able to distinguish between the light emitted by the planet itself and the light from its star, which can easily overshadow the faint glow of the planet. Furthermore, the presence of life, even if detected, is still a far cry from confirming its existence. Scientists need to look for specific biomarkers, chemical signatures that could indicate the presence of living organisms, such as oxygen, methane, or other gases that might be produced by biological processes. The idea of exploring other planets, especially one as close as Proxima b, also sparks the imagination. While sending humans to such distant places may be far off, robotic probes and space missions are steadily moving toward the possibility of interstellar exploration. Technologies like the Breakthrough Starshot initiative, which plans to send tiny light-powered spacecraft to Proxima Centauri at 20% the speed of light, are pushing the envelope on what is possible. These probes would carry advanced instruments capable of gathering data on Proxima B and its atmosphere in real time, allowing us to analyze its habitability more effectively than ever before. However, even as we look forward to the potential for exploration, we must not overlook the ethical considerations that come with searching for life beyond our solar system. If Proxima B is indeed home to microbial life, or even more complex organisms, the discovery could have profound implications for our understanding of life's origin and its spread across the universe. How would such a discovery reshape our view of life on Earth? Would we treat it as a treasure to be protected, or would we risk contaminating another world, as some have worried could happen with the exploration of Mars? These are questions that will require careful thought as we move forward. And then there's the bigger question. Is Proxima B the exception, or is it just one of many Earth-like planets out there? As technology continues to improve, astronomers are discovering thousands of exoplanets in a wide range of sizes, temperatures, and conditions. Some, like Proxima B, reside in their star's habitable zone, but the majority are very different from Earth. Some planets are gas giants that bear little resemblance to our world, while others might be rocky but too far from their stars to sustain life. Yet, as we build up a larger sample size, we may begin to see patterns emerge. Indications of where life is more likely to exist and, perhaps, where we might one day send a probe to search for signs of life beyond our solar system.